All right, so here we are at lesson 1.2 on page 6 of our algebra packet. We're looking at some algebraic properties. This might be a review for you. This might be brand new. Let's take a look at it either way. So we've got the first set of properties is the commutative property. It's the commutative property of addition and multiplication. Really what you need to be remembering is commutative. So maybe you know this word, maybe you don't, but the word commute, that refers to, at least in normal conversation, not math terms, if I'm commuting to work, it means it's my trip that I take from home to work every day and then from work back to home. So when you do a commute, you're kind of moving from one place to another. And if you know that, if you know the word commute, like right now I have a 45-minute commute where I start at the Bronx in the morning where I live, and I commute 45 minutes to Peekskill. My commute is moving from my home over to my job. And if you can remember that, that's exactly what's happening here with my commutative property, either of addition or multiplication. So here I've got, let's try, I don't know, an example with numbers, maybe 1 plus 2 plus 3. So here I can see, I look at it right away, 1 plus 2 is 3, 3 plus 3 is 6. This side will be 6. Now I can move the numbers around, and that's where this word commutative, commuting, comes. So 1's going to commute all the way from its home to its job, which just happens to be on the right side. So if 1's commuting there, that means it's moving over there. I might rewrite this as 2 plus 3 plus 1. Well, 1 just had its commute. It started on the left side. It went onto the right side. But it doesn't change the value. This is the commutative property of addition. I can move my numbers around. They can commute from one side to the other. And it does not change anything. I still get an equation, right? 6, 1 plus 2 plus 3 is 6. 2 plus 3 is 5, plus 1 is 6. If I want to give an example of this with variables, I could say maybe a plus b plus c. Well, if I'm commuting, I'm moving, so maybe I'll move the b over this time. A plus c plus b. B commuted from the middle off to the edge. But this is saying if I have the commutative property, it's addition, it doesn't change. These two are still equal, even though the b moved over from here out to the edge. It commuted to the edge. Commutative property of multiplication, exactly the same thing. Now you don't always need to do it with 3. Maybe I'm going to say 3 times 4, and that's the same thing as 4 times 3. 12 is equal to 12. I move things around, but it doesn't change anything. And so I can say a times b, that's the same thing as b times a. My commutative property means I'm moving things around, and it doesn't change anything for addition, and it doesn't change anything for multiplication. Associative property. This one's also really nice because that word associative, it has to do with the word associate. If you associate with someone, it means that you kind of put yourself in their company, or you consider yourself like part of their group. So if you're associating with someone, you're part of their group. And if you know what that word means, you're not moving, right? You're saying, oh, I'm part of this group. I'm with this set of friends. Or maybe now I'm associating with a different set of friends because I was into basketball before and now I'm playing with the soccer people. And so I'm associating with different people. I'm not moving. I'm not commuting. I'm just changing who I'm with. And that's exactly what the associative property is. It works the same way for addition and for multiplication. For example, I could have 4 plus 5 plus 6, and in this case, I'm going to say 4 and 5 are best buddies. They are associating with each other. And then here I can change who's associating with who. I'm going to say, actually, 4 and 5 aren't best buddies anymore. This time, 5 and 6 are best buddies. Nobody moved. There was no commute happening. No one's driving from one place to another. But the parentheses are saying 4 and 5 are together. And the parentheses here say 5 and 6 are together. So they're associating with somebody different. But in this case, 4 plus 5 goes first because of order of operations. That's 9. 9 plus 6 is 15. Well, here I'm going to do 5 plus 6 first. That's 11. 11 plus 4 is still 15. It doesn't change anything. The associative property says I can change where I'm associating things with only addition, and it's still going to give me the same thing. Here, if you want it with variables, this works with any numbers. So I'll represent them by A, B, and C. In this case, I can say that A plus B plus C is the same exact thing as A plus B plus C. Same thing with multiplication. If I have X times Y times Z, that's the exact same thing as X times Y times Z, except I'm putting parentheses around them in different places. Oh wow, I did that under the numbers example, but you can see it's going to be the same thing. 1 times 2 times 3 is equal to 1 times 2 times 3. Again, nothing moves here. I'm just making different associations, different groupings. 1 times 2 is 2. 2 times 3 is 6. 2 times 3 is 6. 6 times 1 is 6. It doesn't change anything. Distributive property. A lot of people have seen this already. Distributive property, and if you're not familiar with it, that's fine. We're looking at it right now. For the distributive property, let's say I've got something like, and this, notice there's no addition and multiplication because this one is really it's kind of unique, the situation. Let's say I have 4 times 3x plus 2. The distributive property says there is an imaginary, not imaginary, but there's a implied multiplication symbol here. And if I'm multiplying and there's parentheses that I'm going around, I need to make sure to multiply that 4. I need to distribute it to everybody in the parentheses. So I'm going to multiply the 4 times 3, so that becomes 12x. And I'm also going to multiply the 4 times that 2 over there, which will be 8. If we want a purely algebraic version with just variables, I can do A times B plus C. This distribution will look like, well, I'm going to multiply the A times the B and the A times the C. I need to distribute it to everybody. So this will become AB plus AC. And here for the notes, maybe you just want to write distributing. All right. These identities and inverses. If I'm an identity, that means nothing is changing. If I'm an inverse, it means that it means something different for adding and multiplying. But for identity, it's the same. So I'm actually going to do additive identity and multiplying identity together. So for this, it's just for all the identities. Identity, it's what you are. It means it does not change. Even though we're all teenagers and we're in a place of flux and we're all changing and we're experimenting with our identities, you can think of identity, it's who you are. Identity is not changing. You are always you. I am always Mr. Adler. Multiplicative identity is the same thing. Identity is not changing. No change. So if I want to add something and it doesn't change anything, well, I'll add 0. 5 plus 0, that gets me 5. The additive identity is saying, what number do I add to something to make me come out with the exact same thing? And I'll always be doing add 0. So I could do j plus 0. That's always going to be j. It doesn't change it. Plus 0 doesn't change it. Multiplicative identity, instead of doing by 0, I need to do times 1, right? 3 times 1 is 3. It doesn't change anything. Similarly, x times 1, any variable times 1 is just the variable itself. Identity, it means it's not changing. For addition, that means I add 0. Multiplication, I have to multiply by 1. Now, the additive inverse is what I need to add to get to 0. So, what I must add to get 0. So for this, let's say I have positive 6. Well, I would need to add negative 6 to get 0. So I just take whatever I have and I add the opposite. So for example, if I have a, I would need to add negative a. And it doesn't matter what a is, because if I'm adding the negative of it, it's always going to get me 0. That is my additive inverse. The multiplicative inverse is what I need to multiply to get 1. What I multiply to get 1. So in this case, if I have 2, what can I multiply 2 by to get 1? Well, here's where I need to use this word, this idea of a reciprocal, and we need to talk about fractions, which I know a lot of people don't like, but any whole number I can write as a fraction. That is really actually 2 over 1. And the multiplicative inverse, I can multiply this by 1 over 2. If I multiply fractions, you just go straight across. I don't need to get the bases the same. That's when I add fractions. 2 times 1 is 2. 1 times 2 is 2. Any number over itself gets me 1. So the multiplicative inverse, if I have a fraction, I can just flip it over. That's called the reciprocal. If I have a whole number, I put it over 1. Now I have a fraction. I'll flip it over, which is now the reciprocal. I multiply them, and I get 1. This example is actually pretty cool when you talk about just the variables, because now here, even though I'm only using letters, I know that this is actually going to become 1. A times b gets me ab. On the bottom here, b times a gets me ba. But I know because of the commutative property that we saw above, this is actually the same thing as ab over ab. And anything over itself is equal to 1. Finally, multiplication property of 0. If I multiply anything by 0, I get 0. So if I multiply 5 times 0, that gets me 0. If I multiply b times 0, doesn't matter what b was, anytime I multiply something by 0, I get 0. And the reason that makes sense is because this is saying when you're multiplying, it's this number, how many times do I have that number? So here I've got 5, and I have 5 0 times. So that means, well, if I don't have any 5s, I have nothing, it's 0. I have b, I don't know how much b is, but if I have it 0 times, b times 0, b 0 times, well then it's going to get me 0. So that's my multiplication property of 0. That's the notes for today.